Okay, so let's talk about module number 2 homework. I'm going to let you guys answer question number 1 and 2, and we'll talk about number 3 and from there. So it says the EPA limits the rate at which gas can flow into your gas tank when filling up your car at a gas station. Suppose the corner station will dispense gas at a constant rate of 8.9 gallons per minute. Notice that I'm always trying to underline things that just seem important. I think that's probably a great strategy just in terms of like trying to pull out from all the words. 3A says how much gas will be dispensed in 0.8 minutes. So with module 2, remember we defined those different ways of expressing the constant rate of change. In this case, really, it's going to be useful to think about it as a constant multiple. The change in the gallons is always going to be 8.9 times the change in the number of minutes or the change in time. So we're using that constant rate of change and we're thinking of it multiplicatively. Because here, if I'm changing 8.9 gallons per minute in 0.8 minutes, I could simply do 8.9 times 0.8 and I'm going to get 7.12 gallons. I can do the same thing for part B. Now I've increased by 2.6 minutes. So 8.9 gallons per minute times 2.6 minutes is going to get me a change in 23.14 gallons. C is similar, but instead of giving you the change in time, I'm giving you the change in gallons. So we could think about like we have before, but it would be 8.9 times what? I guess I'll put it like this. Times what is going to get us a change in gallons of 15. So to solve, we actually would end up dividing 15 by our constant rate of change. And we are going to get, the answer is 1.685 minutes. So to change by 15 gallons, we need to change our time or increase by 1.685 minutes. All right, for question number 4, given the values in the table, so part A says which table contains values that could define a linear relationship between quantities. Remember that means that there is a constant rate of change, which means really the changes in quantities are proportional. So anytime we need to do that, my first step is to find the changes. So I have my change in X, my change in H, may as well get them all done, my change in B. So when I do this, 1, careful with your negatives. So 1 minus a negative 3 is actually going to be a positive 4. If you think about it, it should make sense that we increased by 4. And then from here to here is 3. When I do this change, I would do 4.2 minus 16.2, I get negative 12. My output decreased, so my change should be negative. Same thing here, I would do negative 4.8 minus a 4.2, I get negative 9. I'm going to go ahead and find these changes as well. So 3.5 minus a negative 2.5 is actually going to be a positive 6. 14 minus 3.5 is 10.5. On the other side, we would do 16 minus a negative 9.2, we get 25.2. And then finally on the last one, we're going to get 45.5. So to ask whether the quantities are proportional for the first one, so I would say, is the change in H over the change in X always the same? So negative 12 over 4, is that equal to negative 9 over 3? And in this case, we are going to get yes. So the first table could defines a linear relationship. For the second one, I don't know where to do this. I guess I'll do it right here. We do change in B over change in Y. And so we would do 25.2 over 6. Is that equal to 45.5 over 10.5? When I put those in my calculator to simplify, I'm going to get 4.2 and then 4.33. Those are not the same, so for this table, it's going to be a no. So to answer part B, it's pretty simple. For the ones that define a linear relationship, determine the value of the constant rate of change. Well, when we do the ratio, it actually does it for us. The answer is negative 3. Let's continue on to question number 5. So question 5 is actually really similar to number 3. It says the cost of a catered party increases with respect, so increases is an important word, with respect to the number of people attending at a constant rate of $18 per person. So if I said like P was the number of people and C is the total cost, we could say that the change in C equals 18 times the change in P, because it's the change in cost is 18 times as large as the change in number of people, or every additional person costs $18. So if the number of people attending increases by 8, right, $18 per person by 8 people, it's going to be an increase of $144, right? If the number of people attending decreases by 13, oh man, all those people canceled, right? We're still going to be changing by $18 per person, but in this case, we're going to be decreasing by 13 people. So we get negative 234. So we could say the cost will decrease by $234. Right? How nice would it be to have a party right now? All right, so sorry. C says if the cost increases by $324, how does the number of people attending change? So now we know the cost of 324, and in this case, instead of multiplying, we're going to divide by the number of dollars per person. Oops, per person, and actually we're going to end up getting 18 people. So the rate in that case is the same as the number of people, and that's going to be an increase because our cost went up. Finally, question number 6 says, the graph given below represents the number of miles until a gas tank is empty, right before refueling, with respect to the number of gallons of gas used. I think of this as like when I look at the dash of my car and it tells me how many miles I am till empty. That's what the output is representing. We're going to assume that the distance remaining decreases, so my rate is negative at a constant rate with respect to the number of gallons consumed. So we first need to describe what these 2 points mean. So the first point would tell me, so I need to think about my units, number of gallons of gas used, miles till empty. So we could say like if we have used 5.2 gallons of gas, we have 275.2 miles until empty. The same idea is true for the second one. So if we have used, in this case, 9.5 gallons of gas, we have, in this case, 172 miles till empty. All right, part B says to determine the constant rate of change and explain what it means. Anytime I'm asked to find the constant rate of change, I honestly am making a table just because it helps me organize things. So 5.2, 275.2, 9.5, and 172. So remember, constant rate of change is change in output over the change in input. So I need to find those changes. So I didn't give myself much space, but I'll do it here. So if I find this change from 5.2 to 9.5, we're going to get an increase, I'm going to put this sideways, of 4.3. So if I have 4.3 more, if I use 4.3 more gallons, if I do 172 minus 275, I'm going to get a negative 103.2. So, oops, a little too low. So here I could say negative 103.2 over 4.3. And I'm actually going to get a negative 24. And the units on that, right, this is miles and this is gallons. So the units here are going to be miles per gallon. And so what that means is every gallon used decreases our miles until empty. I can't spell. By 24 miles. So for every gallon of gas we use, we have 24 less miles we can go until it's gone. Until all the gas is gone. All right, so then for part C and D, we just need to use that constant rate of change. So we could, again, write the ratio. I'll do it up here. Like the change in gas is negative 24 times the change in, oops, sorry, I lied to you. The change in the number of miles till empty is negative 24 times the change in the gallons we've used. Sorry. All right, so for part C, if we increase by 1.5 gallons consumed, I would just do negative 24 times 1.5, and I'm going to get negative 36 miles, right? Because my number of miles till empty will decrease. If I use 3.8 gallons, again, I'm going to multiply, and I'm going to get negative 91.2 miles. So if I use 3.8 more gallons, my number of miles still empty is going to decrease 91.2 miles. And then finally on part D, similarly, but instead of multiplying by our rate, we divide because now I'm given my miles still empty. So our miles still empty decreases by negative 100. We divide by our rate, right, we get 4.17 gallons. And then same thing for the last one. So if we decrease by 58 miles divided by the rate, I'm actually going to get 2.42 gallons. And those are my final answers.